My mention number is 195002. I'll be handling the introduction for our lab video assignment. Now, what we're going to do is we're going to do a beam test. This is the beam machine that we're going to use, which is the SM104 beam apparatus. Now, as you can see here, this is the beam itself, and also this is another type of beam. Well, basically, a beam is a structural analysis type of structure which carries vertical loads. Usually we use beams in bridges, trusses, or anything that can vary which can stand a vertical load. For this assignment, for project, this is one of the beams that we will be using. We will be putting it up here. We do have different types of beams which have different kind of supports, but for this particular assignment, we will only be using a simply supported beam. Now, these are, of course, the loads that we will be using for our procedure. We're going to hang them onto these, and we're going to carry them on the load, which initially we will hope to see a bending, and we can find what is the basically how much weight can this beam withstand.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris and
my name is Sanoli Muhammad Saleh.
so both of us will explain about the methodology on how to proceed with this experiment. Basically, the first step is we need to measure the width and the thickness of this pen. And then Salman, what we going to do?
Next, we measure quarter span from the left and also right side.
And then after we measure the quarter span, we measure the mid span of the span. And then after we already measure the span, we put the span onto the load cell calibration. And then
After that, we take the point load and set it up 1/8 from the center of the beam.
and then after we already set up the point load onto the 1/8 from the mid span, we set the load cell calibration from the quarter from the left and the right of the span. And then after that,
So after that, we calibrate this to 0 to get accurate results.
yeah. So after we already calibrate the load cell to the 0, we take the load and we put the load onto this, and after that we will get the result for this experiment. And then for the next experiment, we will doing the uniform distributed load. For the uniform distributed load,
So this time we will use uniform distributed load, mean single load distributed equally instead of full point load, which is all its weight at the point.
so basically the step is same. We have the same step, which is we have to calculate the width, the thickness of the span, and we have to measure the span. But for this time, we have to measure the span from the left. For the left is for the quarter from the left, and the center of the span, and then the 1/8 from the center, and then the quarter and 1/8, and then another 1/8 from the right of the span. So after we already mark the span, what we gonna do?
Next, we are going to set up the distributed load beginning from here, which is about and 8 from the center, 1/8.
Yeah. Okay, so after we already set up the uniform distributed load to the span, we move the dial gauge to the 1/8 from the mid span. Before this, we put the dial gauge at the quarter of the mid span, and for this time we put this dial gauge into the 1/8 from the mid span. And then after we already set,
After that, we set the gauge once again to 0 to get accurate reading.
yeah, and then after that we will get the final result for this experiment, and we will record the result and tabulate the data. So thank you from the schedule.
We have beam equipment over here, and this is used as the
for the experiment 1, which is the single point loading. So over here we will be actually placing the point loading on a beam, and then this is actually how we can relate it to the engineering field outside. It's actually by, for example, we can take the example of a bridge construction. A bridge can be situated as a beam over here, and for example, a person is walking on a bridge, that particular person can be the point loading. So as the point moves from one side of a bridge to the other end, how can the bridge withstand the point loading or not? Before we construct a bridge, we will be doing the beam test so that we won't be spending much cost on the bridge afterwards. Thank you.
So this is the bridge we use in a test, and this is the lorry. Always doing the test, we should put the lorry on this and make it to a balance and make the system into a stable situation. So this is the bridge we use in a test, and we should put the lorry on this bridge. So this is the distribution, and we should put this distribution on this.
Okay, for the next one is the result. So as we can see, the result is tabulated in a table form like this. And then, as we can see in the table, the W1 is weight that are variables, and W2 is also weight. And as we can see, there are two type of constant. The W1 when we put the variables, and the W2 will be the constant. The next one is R1. R1 is the reading from the reading of scale from the load cell, and R2 is the reading from the load cell of R2 or point 2. And next one is R1 plus R2 is mean the summation of reading on load cell 1 and load cell 2, and the difference between the weight and the summation of R1 and R2. At the next column is the difference between W1 or W2 with R1 plus R2. Okay, the last column is the percentage of the force. And the next table is for the experiment 2 for the distributed load. As we can see, for the first column is W, is small w, represent the distributed load, and W or capital W represent the weight, and R1 also the reading of load cell from point 1, and R2 the reading from load cell at point 2. And the next column is R1 plus R2, and the second last column is also the difference between W and the summation of R1 and R2, and the last column is also the percentage of the force. Okay, that's all from the result.